Welcome to this reminder about variables. In this video, we're going to go back to basics, right to the beginning, and we're going to look at what is a variable. How should we work with them? How should we think of them? What is a data type? And once we've learned all about that, we are going to complete this example in front of us. So let's open up a notepad and let's look at X. Now, perhaps you know what a variable is because you've heard of variables. You work with variables in maths, right? Grade 8, 9, maybe during maths in grade 10 as well. So usually x represents a value. We don't know what the value is yet, and we have to solve the equation to find the value of x. That's what a variable is in mathematics. In coding, a variable is similar, but also not quite the same. In coding, we usually know what is inside of a variable, or at least we know more or less what is in there. A variable in coding is more of like a container that contains a piece of information inside of it, and we can call that variable and call the information that's inside of it whenever we need it. So it's like a temporary storage facility for a particular piece of information, that is. Over here we have sname. This is now a typical declaration of a variable, a string variable. I'm going to come back to what a string, a char, integer, and a real is a little bit later. But for now, let's just look at this part. Here we have sname. This is the name of the variable. So we don't usually work with x or y or z like in maths. Here in programming, we can create our own variables and we can give it our own names, whatever you want. All right. There are a few rules though. The name, which is this highlighted part, the name of the variable should be descriptive of what's going to be placed inside of it. Remember I said that a variable, I said that a variable is like a container. There's my container, and let's pretend, obviously things go inside of containers, right? Let's pretend that this container is called sname. That's the name of the container. Now we can put stuff inside of the container like someone's name, Mr. C. All right, that's my name. So my name is inside of the container called sname. And now whenever I want to use that piece of information which is Mr. C, I can refer simply to the variable called sname. And it'll go and fetch that data for me and place it where I want it. So how do we do that? Here we have sname, and it's going to be equal to Mr. Coetzee. So we're taking this word, my name, and we're putting it inside of sname, right? It's going literally inside of it, just like this picture. It's going inside the variable, inside the container called sname to be stored temporarily until I need it. So how would we use this variable then? Let's make a show message component, right? And we say hello. So we all know what it's going to show. On the screen, it's going to say hello. But let's say I want to improve this program. I want to add on another feature. I want it to say hello and the person's name. So I'm going to say sname. Now this is not going to type hello sname. It's going to substitute sname because this is a variable. It's going to substitute sname with what's inside of it. So what is inside of sname? This, Mr. C, or Mr. Coetzee for short. So it's going to substitute sname with Mr. Coetzee. So this is what's going to appear. Let me add a space after the O as well. It's going to show hello, Mr. Coetzee. You see how it substituted sname? It substituted the variable for what was inside of the variable. I can change S name. Let's make it Kyle. So we run the exact same line of code, except now, having substituted S name, which contains the word Kyle, it displays on the screen, hello, Kyle, instead. So hopefully you can see the power of the variable, the reason why we have it in the first place, because I could just go over here and I could just say Kyle, right? And it would display the exact same thing. But when we are making a program, do you know who's going to use your program? Not really. It could be anyone. It could be a number of people. So I can't code, hello, Kyle. What if Mr. Kutsia comes along and wants to use the program? Then it's going to say, hello, Kyle, but I'm not Kyle. So it would be wrong, right? So that is why we rather put S name here. So whatever is inside of S name, whatever name, it will display that name over here. So let's have a look at how this works in Delphi. Here we have a little report card, and someone's going to enter their name inside of this edit box. The edit box is called EDT name. Okay, that's the name of the entire edit box and whatever is inside of it. So inside of the generate button, I'm going to make my first variable. I have to type var first so I can tell Delphi that I'm about to declare a variable. The variable name is going to be sname, and it's going to be a string variable. We'll come back to that. So sname is going to be equal to, what's it going to be equal to? I'm going to make it equal to this entire edit box, because the edit box is where the user is going to type their name, right? If I run this program, okay, errors because we are still busy coding. Let's comment that out. If I run the program, there we go. I'm going to type Mr. Kutsia. If you're using this program, you're going to type your name, all right? Let's pretend another person comes along and they type Kyle. So we don't know what name is going to be typed in, so we're just going to make S name equal to the whole edit box. And we have to say .text because the name, whatever gets typed inside of an edit box, is entered into the text property of that edit box. All right, so this is going inside of that. Let's visually display that. I first need to rub this out, erase it. I need a bigger eraser. It's going to take too long. Anyways, all right, so there we go. Mr. Kutsia is gone. We are now putting the whole edit box EDT name .text. We're putting it inside of this container called sname. We don't know what the name is. It's going to be different depending on who's using the program. But we know that whatever they type is going to be put into sname. All right, let's display that. We're going to display this in this little label called LBL subject. So we'll say LBL subject dot caption is equal to, and we're gonna first put the word subject there, a little space, and we're gonna add sname afterwards. So what should happen is it should show the word subject exactly how I typed it, and then it should substitute sname with what was typed in by the user. Okay, technical difficulties. Let me just go ahead and delete those. There we go. Perfect. So let's start by saying Mr. Kutsia with too many capital letters, and I click generate. There we go. Subject, Mr. Kutsia. Okay, that makes no sense because that is not a subject. That is my name. We should probably change this. Okay. I don't know why they didn't make a label for the name, but whatever. Mr. Coetzee. Here we go, name, Mr. Coetzee. Alright, so you can see there, I typed the word name and it appeared there, name. But where I said S name, it substituted that with what was typed in the edit box and then placed in S name, which is Mr. Coetzee. Let's try a different name. We can see now it says name, Kyle. Right, so whatever name you type in here, it's going to store it in the variable called sname. And like I said, a variable is like a temporary storage facility. Okay, and the name is temporarily stored inside there until we call it when we need it. Okay, so I said that I'm going to explain to you what is the string that I typed over here. Now, this is called a data type. Every variable must have a data type. The first one we'll look at is string. Now, if you go maybe to a primary school, grade 3, grade 4, and if you walk into a class and the learners are busy making like a homemade necklace, all right? So what do they use? They have a piece of string and a whole bunch of beads, and they put all the beads on the string and they tie it up and put it around their neck. So we have a string holding together all the different beads. Now that's kind of how this is working, right? A string data type is a bunch of characters put together. So Mr. Coetzee, you can see that this is a whole bunch of characters, right? We have M, we have R, we even have a space, which is a character on its own, and then the rest of them like that. They're threaded together like beads on a string, and they're placed together like that. Now, it doesn't have to be a name. It can be a sentence. I want to go to the shop, with a full stop as well. Right, there we go. We have a sequence of characters placed together, and we call it a string. Now we can see that characters, when I say characters, I don't just mean letters of the alphabet. It includes the spaces, it includes special characters like punctuation as well. And I went to the shop 5 times. Right, we even have a number in here. Although this is not really technically a number at the moment, it's also classified as a character. But any kind of character can be placed inside a string variable. Next up, we have a char data type. Now, a char data type also holds characters, but with a limitation. It can only hold one character. So while a string can hold many characters, a char can ever only hold one character, like a G, or an R, or a 5, or an exclamation mark, or a full stop. Right, so any character, doesn't matter which one, but only one, never more than one. Okay. Now we move on to integer. And an integer, now we're talking about numbers. So unlike the first two, which can hold characters, integers, number data types, can only hold numbers. So the number 5, for instance. Now, what's the difference between this 5 and that 5? So the 5 here at the top is in a string data type, so it's not seen as a number, not a mathematical number. It's seen as a character that happens to be a 5. When we put 5 inside of an integer data type, it is now not a character anymore. It is a number. That means we can do maths with it. We can take this 5 and we can add it to another integer number, or we can subtract it, or we can multiply it, or we can check if 5 is bigger than another one. You understand? And that's because it is now listed as an integer. You must realize that Delphi is a programming language, right? And computers, they don't know what's what. You have to explain everything to the computer very simply. You have to tell the computer that this 5 over here This is just a character, it's just a string. It's not meant for maths. And then you have to tell the computer that this 5 over here, okay, this is not a character. This one is meant as a number so that we can do math with it. Now, integer, just like in maths, is a whole number. So you can never have a decimal value. You can't have 5.2, 5.5 in an integer. It can either be negative numbers, 0, or positive numbers, a whole number. But we have another data type called real. Now, real is everything that an integer is, for the most part, but it's not an integer, it is a real number. Hopefully you remember what a real number is, right? A rational number, and that includes decimal numbers. So it can be 5 on its own as well, but it can also be 5.8, or it can be 3.1754, whatever, like that. So it can hold decimal numbers as well. And the last data type that I'm going to show you for today is a Boolean. A Boolean is either true or false. It can't be anything else. It's either yes or no, on, off, true, false, just like that. So we're not going to really do anything with Boolean today. We're gonna use these 4 data types, okay, not char, but we're going to use string, integer, and real in our little program. So we've already done the first one, okay. We have over here is name. We have now another one for subject. So we have a space, an edit box where the user is going to type the subject. So we should make another variable. Now, when somebody types out what subject they're doing, what data type do you think that's going to be? They're writing out a word, right? Like information space technology, or computer application technology, or mathematics, or English. So it's characters, a lot of them. So we should probably make a string. S subject with 1C. Now, the subject part is the name of the variable. So the name has to be descriptive. I don't know what subject the user is going to type in, but I know that they're typing in a subject, and it's going to get stored in here. So it's descriptive. The S is just added in front so that when somebody reads the code, they know that this variable is a string. The S stands for string. So let's do that. S subject is going to be equal to, where they're typing it into edt subject. Edt subject dot text. And now we can display that if we wanted to. I want to move on to these two. This is now where someone is going to enter the marks that they got for their test. So let's pretend that the first mark is their practical mark and the second mark is a theory mark. But of course they're typing in marks, right? So that means it's going to be numbers. So not a string, perhaps an integer, let's say out of 100. So we must make another line of variables over here. And this time I'm going to say I practical and I theory. And that is going to be an integer. Both of them are going to be integer variables. So practical is the name of the variable, and it's descriptive. I know that the practical mark is going to go in here, and the theory mark is going to go in there. And the I is just to let me know that these two variables are not strings, they are integers. So let's capture the variables, let's capture the data from the user. So I practical is equal to, and they're going to type the practical mark in edt mark 1. edt mark 1 dot text. All right. We see a little red line over here. We know that we must have that semicolon. So let's have a look and see what is Delphi complaining about. Over here in the top left, we can see a little error message. It says incompatible types. We have an integer, which is iPractical, and a T caption, which is referring to the dot text property of EDT Mark 1. Now the .text property is always going to be a string. So even though the user typed in a number, because they typed it in an edit box, the computer thinks that that number is not a number, but a string. So we have to correct the computer, and we have to tell it that this string must be changed into a number, so it can go into this number variable called iPractical. We can do that very easily by putting brackets around what the user typed in. And just to show you, I'm going to make a comment here. We are going to convert this from a string to an integer. And we can do that simply by adding string, str, to int. There we go. And obviously this stands for go from a string, because it currently is a string, to an integer, so that you can go and be stored in this variable called iPractical. Let's do the same for the other one. iTheory is equal to string to int EDT mark 2 dot text. So I've now captured both marks from the user. I have them temporarily stored in these two variables, and I can call these variables whenever I need those marks. So we should probably display them on the report card in this label, the first one called LBL mark 1. So let's do that. LBL mark 1 dot caption is equal to, and I'm going to say here, practical mark plus iPractical. So it's going to display the word practical mark, and then it's going to display not iPractical, it's not the word, it's going to substitute that for the mark that the user typed in. But we have a red line, we have a syntax error. So let's see what it's complaining about over here. Incompatible types. We have a string, which is referring to the dot caption, and we have an integer, which is iPractical. Now you can't put an integer into a string, and you can't put a string into an integer. They have to be the same. So one must be converted. Okay, we can't convert this. We never convert what's on the left-hand side of the equals. We always convert what's on the right-hand side, because the right-hand side is going into the left-hand side. So we're going to put brackets around iPractical. Now iPractical must be converted to a string. So we're going from an integer this time to a string. So we've got brackets around it. And I'm going to say go from an int to a string. See how simple that was? We're going from an int to a string. So iPractical is being converted so it can be displayed in the caption. Let's do the same for the second one. LBL mark 2 dot caption is equal to theory mark plus int to string iTheory. So let me type my name in, Mr. Kutsia. Let me type my subject, info technology. My first mark for my practical was 80 out of 100, and for theory, because I studied, I got 90 out of 100. Let's click on generate. We have our name, Mr. Kutsia. We have our practical mark, 80. So can you see over here, this part, practical mark, it displays exactly how I typed it out. But here, where we said iPractical, it substitutes the variable iPractical with its contents, which is what the user typed in over here. So 80. I made a mistake. The same mark is being displayed for prac and the theory. Maybe you picked up on that. If so, very good job. iPractical is equal to EDT mark 1, but iTheory is equal to EDT mark 2, right? The second one. My bad. Okay. Mr. Kutsia, again, 80 for the practical, 90 for the theory. There we go. Theory mark is 90, practical mark is 80. There's one thing left that we have to do before we end, and we have a spot over here for the average of the 2 marks. Now, how do we work out the average of our marks? We have to add the 2 marks together, and then we must divide by the number of marks we have. How many marks we have? We only have 2 marks. So we're going to say I mark 1 plus I mark 2 to add them together. And then we're going to divide the answer by 2, and that'll give us the average. So we're going to make a real variable to hold this answer. Why a real? Why not an integer? Because we're dividing. And whenever you divide, there's a really good chance that you might get a decimal value. Right? We can't have decimal values in integers. So we have to protect ourselves. So we're going to say our average, and that is a real data type. Can you see that, again, average is the name of my variable, and it's descriptive. It's when I see average, I know that the average mark is going to be in there. I don't know what it is yet, but I know it's in that variable. And again, I add the R in front so that whoever reads this code can very easily see that it is a real data type, not something else. So our average, I'm going to do the calculation and I'm going to put the answer into our average. So I'm going to say I mark 1, not I mark 1, I practical mark plus I theory mark. Right, so we're doing what we said we're going to do in the first one here. We've added them together. Remember, I don't know what the user is going to type for the practical, and I don't know what they're going to type for the theory. So I can't actually write the numbers here. I have to use the variables instead. And I'll put brackets around it just to ensure that BODMAS does its thing. And then I'm going to divide by how many marks we have. We only have 2 marks. All right, so this is going to calculate, and it's going to give an answer, and the answer is going to be stored in this temporary storage location called our average, a variable. Now all I need to do is display it. Right, here we have a label called LBL average. We'll display it in there. LBL average dot caption is equal to, and I'm going to say average mark, and I'm going to add our average with an E. All right, there we go. So it's going to substitute this with the average, but I have a red line. So let's see what the red line's all about. Here they say incompatible types. We have a string and a real. Okay, they have to be made the same. They can't be different. So we know that when we're talking about a caption or a text, but a caption in this case, it has to be, whatever goes inside of it must be a string. So our average must be changed from a real to a string. So underneath here, I'm going to make a comment. We are changing from a real to a string. So we put brackets around our variable. And you might think that we're going to say real to string, right? But not quite. In programming, a real is often referred to as a float, right? Sometimes, like when we declared the variable, we said real, but it's also called a float. Now, you don't have to really understand why. I mean, you can go and look it up. I'm not going to try and explain it now, but we have to say float to string. But it's exactly the same as saying real to string, because this is a real, and it's also a float. Okay, we can use them interchangeably. So we're going to go from a float to a string so that we can display it inside the caption. All right, let's run our program for the last time. Mr. C is my name. I got 80 for my practical test, and I got 90 for my theory test. Let's generate a report. Okay, name Mr. Kutsia, practical mark 80, theory mark 90, and my average is 85. Now in this case, our average was a whole number, but it might not always be like that. Let's say that I got 79 for my practical mark, and I got 85 for my theory. Up, still in. Let's try another mark. How about 89? Still old number. Ah, finally, okay. Jeez, we've got a decimal value. All right. Now, if this was stored in perhaps an integer variable like I_average, the program would not work. We would get an error message because a decimal value, 84.5, cannot be stored in I_average. It must be a real variable, R_average. All right, and this brings us to the end. Now, this is just a really condensed video about variables, right? So we got a lot of information in one like 20-minute video. If it was a little bit too fast-paced for you, you can always watch the video again. But what I suggest you do, if you really want to get a handle on variables, and you have to, if you are struggling to understand this, you really got to get a handle on it, because you won't be able to carry on with anything else until you got this down. So in chapter 3 of the Department of Education textbook, we have a whole chapter about variables. We have data types, variable names, declaring variables, assigning values, and converting data types. All of this stuff we've done in this video. All right. But if you want to look at them in more detail, if you want to do exercises on each one, go through this chapter. And there is one extra thing that we didn't do, a little bit more advanced. There are two types of variables. Here today we've worked with local variables, but there's also another one called global variables. And if you want to learn about that, we have to go down to chapter 4, not the first part, just here where it says unit 4.4, and it says variable scope. Variable scope can either be local or global.